Hi, I'm Nataraj Nagaratnam, and I'm from IBM Cloud. Traditionally, when you deploy an application, you have the entire data center, the servers that you run, you're responsible for all of it. In the cloud model, that's a shared responsibility between you and the cloud provider. In a shared responsibility model, you need to rethink security on what your responsibility is and what cloud provider's responsibility is. Let's take platform as a service as an example. When you look at PaaS, you're building applications, migrating data to the cloud, and building applications running on the cloud. So you're responsible for securing the applications, the workload, and the data, while the cloud provider is responsible for managing the security of the platform so that it's compliant, it's secured from the perspective of network, the platform on down in terms of managing the containers, the runtime, and the isolation so that you have your own space within the platform. Whereas if you are adopting and migrating workloads to the cloud and you're using infrastructure as a service, then the cloud provider manages hypervisor on down if you're using virtual servers. Or if you're using bare metal, then you can completely control everything on up from the operating system, the virtual servers that you run, and the data you bring it on. So it's very important to understand the adoption model, whether you're consuming IaaS or PaaS, or if you're consuming SaaS, where the cloud provider manages all the applications and the security of it, and you worry about the data that you bring in and plan accordingly. So that's a very important thing because it's part of understanding your responsibility in ultimately managing the risk and compliance of the workloads and the data that you bring to cloud. Now, let's talk about architecture. When you build applications and migrate applications and modernize your apps, let's start with data. With all the risk that you deal with, and the kind of data matters. Is it confidential data? Is it public data or sensitive data that may deal with private information? Consider all those factors and make a secure design around what your data security architecture should be. Make sure you have data at rest encryption so that the data is always encrypted, whether you use a database as a service, object store as a service, or other ways to store data like block storage. Encryption is for amateurs. If you think about key management, that's for professionals. So having more control of your keys provide you the ability in the context of shared responsibility model that you own your data, you have complete control of your data. So as you think about key management, make sure you have an approach to think about if you're bringing confidential data, you want to bring your own keys. Maybe sensitive data, you want to keep your own keys. So that how much control of the keys you have and the hardware security module in which the key processing, the encryption, decryption operations happen, more control you have, more responsibility that you can take on. So encryption data at rest, data in motion, as it comes from services to data stores or applications, so that as you think about data coming all the way, your requests and API requests coming all the way, data in motion. And in the new world, we need to start thinking about when the application is actually processing the data, there is going to be data in its memory. So you can actually start to protect data using hardware-based technologies where you can protect in-memory data as well. So that when it is in use and in memory by the applications, you can protect it. So take a holistic approach to data protection at rest, in motion, in use, with full control of your keys. It can be bring your own keys, or even better, push the boundary with keep your own keys. The application that serves the data, it's not only about which application needs to have access. Make sure the data access is on only a need-by-need basis. Do not open up your data services to the whole world, be it network access or everybody to access the data. Make sure you exactly know which applications need to access or which users need to access the data to run your cloud applications. From an application viewpoint, make sure there are no vulnerabilities in your application. So scan your applications. So have an AppSec application security approach so that you can do dynamic scanning or static scanning of your application before you deploy it into the production. And in the cloud native environment, you're deploying container images. So you can scan your images. You can scan it for vulnerabilities before you deploy and set your policy so that you only have secured images in production anytime. And if there's any vulnerability in the new world, you don't need to patch these systems. You just spin up a new container and off you go. So that's the beauty of a cloud native approach, that you have security built in every step. So at a container level and the applications that serves the business logic, you can start to protect it. Then when you look at the users coming in, you want to manage access in terms of who the user is and from where they are coming from. So identity, you need to make sure who the user is or which service it is based on the identity of those services or users so that you can make access control to your application or data. And also from the perspective of network access, you want to make sure only authorized users can get in. And if there are intruders out there, you can make sure you can set it up so that they are prevented from accessing your application and your data in the cloud, be it through web application firewalling, network access control, or distributed denial of service protection, and have intelligence built into these network protection as well. So both identity and network. In essence, you are protecting your data. You need to manage access to your apps and the workload and the data that you have deployed on the cloud.